What's up, Algebra 2 people? Thanks for stopping by for this trig identity video that's a little bit different than the first one we've talked about. But basically a question that I might ask you looks something like this. So far, we've kind of talked about if we are given sine or cosine, we have to find the other one. Well, there's another option where I might give you tangent of an angle and then have you find both sine and cosine. So a couple things that we need to know about this is, first of all, there's a new trig identity that tells us basically the relationship between tangent of an angle and sine and cosine. Because if we think about the unit circle, we've already talked about how if we create a triangle from some angle, that the y value is sine of theta and that the x value is cosine of theta. Because our hypotenuse is 1, so we know that the opposite side is sine of theta, the adjacent side is cosine of theta. That's something that we already know. Tangent, the other thing to remember is that tangent of an angle is always the opposite over the hypotenuse. And in this case, the opposite is sine of theta, and the adjacent is cosine of theta. And so this is our other trig identity. Basically, the tangent of an angle is equal to sine of that angle over cosine of that angle. And I'll show you how this helps us find sine and cosine if we know what tangent is. And we'll come back to the degrees here helping us out as well. So first thing that I need to know is that I'm basically just going to take sine and cosine and I'm going to set it equal to this 1/6 here. So sine of an angle over cosine of the angle equals 1/6. Next, I'm going to solve for sine. So I'm going to multiply both sides by cosine of the angle because I want sine by itself. So now I know sine of theta is equal to 1/6 times cosine of theta. So far, nothing too crazy. Now, though, I'm going to use the other trig identity to help me solve. Remember, if you don't, the other trig identity is sine of theta squared plus cosine of theta squared equals 1. So basically what I'm going to do is I'm going to plug in this sine into here. So what that looks like is I'm going to have 1/6 cosine of theta, because I know that's equal to sine of theta, squared plus cosine squared of theta equals 1. So again, I just took all of this and replaced it for sine. So now I have just cosine, and I can do some algebra to solve for cosine. Let me scroll down here, and now let's do a little bit of math where I square this. 1/6 squared is just 1/36. And then cosine squared, we just write as cosine squared of theta, plus cosine squared of theta equals 1. Now, here's where it gets a little bit tricky, because don't forget cosine squared of theta. Just like if we have like 2x squared plus 3x squared, I can add the coefficients to get 5x squared. I'm going to do the same thing here with the cosine squared theta. So I'm going to take 1/36 cosine squared theta plus 1. And again, for those of you that are terrible at fractions, don't forget, if I'm adding these two together, it's really like saying 1/36 plus 36/36, which in this case is going to be 37/36. Again, lots of little things that we're putting together to create this, so don't be too stressed out so far. We got 37/36 times cosine squared theta equals 1. Now we are going to try and get cosine squared theta alone. So we're going to divide both sides by 37/36, or multiply by the reciprocal, because I want to get rid of that, because that would cancel out the stuff on the left and leave me with just cosine squared theta equals 1 times 36/37, which is just 36/37. I take the square root of both sides, which is the same thing as the square root of 36 over the square root of 37, which is the same thing as 6 over the square root of 37. And I also don't want a square root in the denominator. Man, there's a lot of steps to this. Nothing that you can't do, though. I totally believe that. So that gives me 6 root 37 over 37. And boom, that is what cosine of theta is equal to. 6 root 37 over 37. Again, just like our other trig identity, we're going to have to figure out if that's positive or negative, but we're going to come back to that. The other thing, though, don't forget, is that we were originally asked to find sine and cosine. So what I'm going to do is I'm going to use, let's see, in blue here, I am going to use this part of my equation because I know now what cosine is. So if I plug that in, I can find what sine of theta is. So what that means is I have sine of theta, just rewriting that, equals 1 over 6 times cosine of theta, which I now know is 6 root 37 over 37. And if I were to simplify that, the 6's cancel out, and I'm just left with root 37 over 37. So then my sine of theta equals root 37 over 37. And boom, that is what cosine and sine of theta are equal to. Last step, though, we have to know if it is positive or negative. And let's think about this for a second, because if I go back up here, it told me originally that 180 degrees. So our angle was between 180 degrees and 360 degrees. And if you remember from our unit circle, on the bottom left here, both the cosine and sine were negative. In the bottom right here, the sine was positive, the cosine was positive, but the sine was negative. And in this case here, remember, it's sine divided by cosine is equal to tangent. So since tangent, we had a positive tangent, that means that the sine and cosine either had to be both positive or they had to be both negative to make that tangent positive. In this case here, since it's one of these two combinations, it has to be both negative. So my final answer for both of these are both going to be negative. A ton of steps in this here, and I totally get that it might seem a little overwhelming, but these are all like little steps that you already know for the most part, except for obviously the new trig identity, like what's in purple here. But basically, it's all stuff that you're able to do. We're just combining a lot of things into one type of a question. So take a look at these, some practice problems on the little mini study guide that I am giving out today. And if you have questions on it, let me know. Otherwise, we'll go over it on Monday. Talk to y'all soon.